Hi students, in this video we're going to look at how to analyze scatterplots. Right, so after watching this video, you should be able to describe the correlation between two variables shown in a scatterplot by referring to the strength of the correlation, its direction, and its shape. You should also be able to write a bit of a paragraph, a few sentences, describing what this correlation means in everyday language. So the biggest thing you'll have to remember how to do is create scatterplots. So using your explanatory variable along your x-axis, your response variable along your y, and your data points in that grid on that plane. Now, correlation refers to the nature of the association between two variables. So it's talking about if you've got two variables, how are they linked together? That's what correlation is. And so the correlation can be described using three key terms and ideas. So the strength. So how closely are they related? Are these variables sort of related to each other or quite related to each other, where a change in one definitely means a change in the other? The direction, right? So how does one variable change as the other one changes? Does it increase, does it decrease, or does it stay the same? That's the question of direction. And then shape. Well, over time or over a long period or using a big sample, what sort of model can be used to describe this correlation? Is it straight line? Is it curved? What sort of curve? That sort of question is what shape is getting at. All right, so strength refers to how close the link is between two variables. And there's a few different words and pieces of vocabulary we can use to describe that. So this first one, for example, this is a perfect straight line. So we can actually call that one perfect. This second one, it's not quite a straight line. This one here maybe looks a little bit out of place. But it's still basically a straight line. So we'll call this one here strong. This third one, again, you can still see that the data is heading upwards. Okay, it's definitely increasing. There is some sort of link there. It's not quite strong. We might call this one moderate. This last one. This one's a bit hard to tell. This one I'd say is probably weak. Generally speaking, the data is still increasing. It's not quite as obvious as the previous one. So we'll call this one a weak correlation. What's really throwing me off a little bit is this data point here. This one here looks a bit like an outlier. If we ignore that one, the correlation looks pretty good. It's definitely in that moderate range. This outlier here makes the correlation a bit weaker. This last one, there's no real link between these variables at all. The dots are quite random. There's no pattern to them. So we'd say for this one, there is no correlation. All right, now strength can't, it can be seen just by looking at a graph, but it can also be quantified. So that is, it can be given a number. Now, the two main ways we do that in statistical analysis is using Pearson's correlation coefficient. We call that R, and the coefficient of determination R squared. We won't get into those two here. Those will be for future videos, but it's worth knowing that we can actually put a number on how strong the correlation is between two variables. All right, direction. Direction of a correlation describes how one variable changes if the other has changed. Basically, does it increase, does it decrease, or does it stay the same? In this case, positive correlation means as our explanatory variable on our x-axis increases, our response variable increases too. So what that looks like in this situation, in this first one, is these data points are all trending upwards. So this one is a positive correlation. In this second one, the data points are all trending downwards. So as we increase in our explanatory variable, our response variable is going downwards. Right? That's where negative comes from. Right? It's negative because our response is moving downwards. So that's a negative correlation. All right, finally, shape. So shape informs us what type of relationship, what type of correlation exists between the variables. It can refer specifically to some type of function, exponential, parabolic. It's limited by your own mathematical understanding, but generally we can also just describe it using broad categories. So linear, so the data could be modeled by a straight line, like in this first one. So that one would be linear. Or non-linear could be modeled by a curve or a series of curves or lines. So this second set of data looks a bit more curved. So that one would be non-linear. Okay, and then shape. That can be further analyzed using residual plots. Again, not going to be covered in this video, but look out for that one as you continue in your studies. All right, now when analyzing a scatter plot, we want to have a few key sentences to do, on at least two. Options can increase from there, but two is a minimum. 3 or 4 make a good paragraph. Now, how do we make that paragraph? How do we describe our scatter plot? Our first sentence is a correlation statement. So we're going to talk about using those 3 ideas: strength, direction, and shape. We're going to talk about whether or not there's a strong, moderate, or weak correlation. So that's our strength. It's positive or negative. So that's our direction. And then is it linear or non-linear? That's our shape. And then there's a correlation between our explanatory variable, whatever that is, and our response variable. So don't use those exact words. Actually tell me what the explanatory variable is and what the response variable is. After that, we're just going to translate that into a normal sentence. So as the explanatory variable increases, the response variable will, then you can here use some modality. Okay, and this modality, right, your certainty or your strength of what you're saying relates to the strength of your correlation. So if you've got a strong correlation, you could say it will increase or it will decrease. If there's a moderate correlation, you might say it will generally increase or decrease. If you have a weak correlation, you could say the response variable might increase or the response variable will possibly increase. You can change your modality based on how strong the correlation is in that statement. And then finally, you can include some other sentences looking at either adding a sentence about the evidence, to include the highest and lowest data points, we call those top and tail, and show how the data is increasing or decreasing. And then, or you can explain why this relationship is the way it is, or why it's not quite what you expected. All right, so let's do an example. Scatter plot left shows the rebound height of a ball when it's dropped from different heights. Let's describe the correlation between the data. So some things we can see straight away. The strength, it's somewhere between strong and perfect, right? It's almost a straight line. We'll go with strong for this one. It's positive. So as the drop height increases, the rebound height increases, and it looks pretty much like a straight line. So we can say that in our sentence. So there is a strong, positive, linear correlation between our explanatory variable, the drop height of the ball, and the rebound height of the ball. So there's our correlation statement, nice and clear, using all of our mathematical terminology. And then our second sentence, just translating that into common everyday terms. As the drop height increases, the rebound height of the ball will also increase. Notice the modality, it says it will increase because that's how strong our correlation is, right? Again, we've got almost that perfect straight line. So as the drop height increases, we can be very confident that the rebound height will increase when the drop height increases. Now, what might those other optional sentences look like? Again, if we're talking about our data or our evidence, we can say the ball dropped from 0.3 meters. So this data point here has a rebound height of 0.24 meters. And when the drop height is increased, there's our key word, is increased to 1.8 meters, the rebound height also increases to 1.25 meters. So we're talking about our variables, we're including our data, we're stating our trend again. It sounds very similar to our everyday language sentence, but it's including the data, it's showing the evidence for our conclusion. Now, if we're explaining it, again, we just want to see that the cause and have a nice clear reason. In this case, it makes sense. Right? This happens because the ball dropped from a greater height starts with more energy than one dropped from a lower height. And then after the ball dropped from the greater height bounces, it still has more energy than the ball that started off at a lower height. So it means it can bounce higher because it's still got more energy. Doesn't have to be long, but that's a clear explanation, couple of sentences there. Right, so after watching this video, you should be able to describe the correlation between two variables shown in the scatter plot, referring to the strength, direction, and shape, and then describe the correlation in an everyday language using a nice paragraph.